The James Webb Telescope is our eye in the sky, peering deep into space to bring the universe closer to us. When the impossible is determined, science becomes clear. The James Webb Telescope captured a comprehensive image of Proxima B, our closest exoplanet neighbor, in one of its orbits. However, something strange happened. What could it be? What mysteries has the James Webb Telescope still solved? Listen in to find out what that means and why the world's largest space observatory is no surprise. The James Webb Space Telescope, JWST, was built with the goal of revolutionizing infrared astronomy. This space telescope exceeded the capabilities of the Hubble Space Telescope because it made it possible to observe objects that were previously inaccessible due to age, distance, or darkness. It includes state-of-the-art equipment and a lot of attention and determination. This revolutionary potential opens many avenues for astronomical and cosmic research. 6 major constellations have been discovered since the beginning of the universe, which is amazing. These important properties can change our understanding of the nature and evolution of galaxies. The powerful infrared instrument of the James Webb Space Telescope collected the data, and the findings were published in the famous journal Nature. With this information, it is possible to see what the Earth was like 13.5 billion years ago, when it was only 3% of its current age. Amazingly, these hypothetical galaxies, 500 to 700 million years after the Big Bang, have already reached the same level of maturity as our 13-billion-year-old Milky Way. The mass of stars of these objects is estimated to be billions of times greater than the mass of the Sun. According to this study, the mass of one of the stars in this constellation would be 100 billion times that of the Sun. The stars in our Milky Way have a mass equal to 60 billion suns, which helps to understand this. As a reminder of the vastness and complexity of the universe, this discovery challenges our previous assumptions about the nature of galaxies. It also provides exciting insights into the early stages of galactic evolution. You may be surprised by what happened after James Webb discovered the telescope, which has many implications for this study. Erica Nelson, one of the authors of the study and an astrophysicist at the University of Colorado Boulder, was surprised by the rapid growth of galaxies and the number of stars like the Milky Way. He said the findings were surprising. He also discovered a planet in the Centaurus B star system, which is 11 times larger than Jupiter, the largest planet in the solar system. Since these two stars have similar masses, the Centaurus B star system is known as a young binary system. The distance between our planet and this star system is very large, about 3,125 light-years. Centaurus B is one of the largest planets ever discovered. It revolves around 2 stars that are larger than our Sun and 6 to 10 times the mass of our Sun. The Centauri system is the largest system to host a planet. Additionally, Centaurus B is known to have the highest temperature among host star systems. The 2 stars Centaurus B, also known as Centaurus A and Centaurus B, are about 15 million years old. On the other hand, our Sun, a G-type main sequence star, is much older, more than 4.5 billion years old. Although the stars of Centaurus are still young, they have entered stages of stellar evolution that have shaped their properties and influenced their future growth. Scientists hope to find small, young galaxies early in the universe's evolution. Ellebra, the study's lead researcher and a researcher at Australia's Swinburne University of Technology, described the galaxies as monsters that appear to be accelerating. Because of the mystery of the aging rate of these galaxies, scientists want to know more about this phenomenon. They also found Proxima Centauri close to the star Centauri B, which is even more exciting. A red dwarf star less than 4 light-years from Earth is Proxima Centauri. It is known for the large and powerful flames it produces. These powerful bursts of stellar energy have a profound effect on the planets orbiting the star. The radiation emitted from these flares could adversely affect the surface and atmosphere of Proxima Centauri B, potentially destroying its life-giving atmosphere. The intense radiation from Proxima Centauri's flares could be harmful to the planet. On Proxima Centauri B, complex life might have trouble evolving if they were exposed to high radiation levels that made it hard for them to survive and reproduce. Despite these obstacles, scientists and astrobiologists are intrigued and excited by the possibility of a life-sustaining environment on Proxima Centauri B. Using sophisticated computer models similar to those used to study climate change on Earth, researchers have discovered that Proxima Centauri B can maintain vast areas of liquid water on its surface under a variety of conditions. This exciting development significantly boosts the probability that the exoplanet can support a variety of life forms. Scientists still don't know much about the planet next to Proxima Centauri, despite its proximity. The planet's mass is 1.3 times that of Earth, and it orbits its host star once 11 times a day. Because of the lack of information, scientists eager to learn more about this fascinating celestial body face a unique challenge. As a result, we face an important question. Is life possible on Proxima Centauri B? Proxima Centauri B is a planet that orbits far enough away to have enough light from the star to keep its surface warm enough to stay above water. It lies in the habitable zone of its parent star. This large area of the world indicates that water exists on the surface of the Earth because water is essential for life. However, it is interesting to note that the planet Proxima Centauri B is locked in its orbit close to the star due to the gravitational pull of the vacuum. A tidal lock is like the connection between the Moon and the Earth, only one side of which we can see. The tide is locked when the planet faces the star on one side and remains dark on the other side. There are two possible configurations for Proxima Centauri B's atmosphere. Early in Earth's history, a process occurred that cooled water and sent hydrogen into space, leaving the atmosphere with oxygen or carbon dioxide. If Proxima Centauri B had a star or a primordial hydrogen gas, the water flow would be low. For this reason, Proxima Centauri B could have retained its initial water source. If a planet had an atmosphere, it would have oxygen and carbon dioxide. When these winds interact with the star's magnetic field, they can create auroras that can be seen from Earth, indicating that the planet has a magnetic field. There are many more. Climate models, like the general circulation models used to model Earth's climate, have been used to model the atmospheric conditions of Proxima Centauri B. These models take into account the tidal lock of the world, the existence of water and carbon dioxide, etc. Confirmed. The influence of Proxima Centauri B has several implications. It will cover all or part of the planet in ice. A planet the size of an ocean or small body of water. Locations are also available for all types of countries. Some examples point to unusual features such as eyeballs and, crab-like, areas filled with water that look like claws emerging from the equator. In addition, researchers hypothesize that there is an ocean beneath the surface of the thin, slowly receding ice sheet, which changes thickness over time. Using weather models, scientists can study the conditions of Proxima Centauri B and speculate about the conditions of this distant planet. So, could Proxima Centauri B support life? The existence of Proxima Centauri B is challenging because of the intense ultraviolet and X-ray radiation from this star. The planet experiences higher levels of radiation, especially X-rays, than Earth. 7 to 16 times the XUV radiation in the world and more than before. This radiation can be absorbed by hydrogen and trapped there to escape the Earth's gravity and enter the atmosphere. The hydrogen in the outer atmosphere of the planet burns to the point where it is pushed by radiation, and the water splits into oxygen and hydrogen. As a result of this process, other elements such as nitrogen and oxygen are also lost. Even if only nitrogen and carbon dioxide are removed, their concentration on the Earth's surface may not decrease significantly.